Hi guys, Mr. Janowski here. Here is the second problem from the new and improved study guide. So we're going to try to figure out the work done by four different forces: the force of Alice, gravity, the normal force, and the force of friction. As Alice pushes the sofa across to the right across the floor through a displacement of 3.25 meters. So if we're going to do step what are we looking for, and what units do we expect it to have? That's a terrible question mark. Sorry, the stylus is not very good. Okay, I'll just write it for the first one because that's all I'm going to have room for. We're looking for the work done by Alice. So W sub A is equal to question mark, and the units will be joules. Joules are the units for work. Now to do this, we need to know our formula for work. So if you check the footer at the bottom of the page, you're going to see that work is equal to the magnitude of the force times the magnitude of the displacement. All right, that's an F, times the magnitude of the displacement times cosine of theta. And what does theta represent? Theta is the angle between the force you're looking at and the displacement of the thing itself. So keep that in mind. You need to know what the displacement of this object is. In this case, the sofa moves to the right across the floor through a displacement of 3.25 meters, and it may be helpful for you to add the displacement vector to the free body diagram. So what that means is this thing actually does go this way. So D is equal to 3.25 meters. So that would be the displacement in all four cases. It's important to know that, and it's important to know what the angle is. So now let's figure out what all of our angles are going to be. So starting with the angle between Alice's force and the displacement, that's the most obvious one. That's this angle right here. So let me call this theta sub A, the angle of Alice's force, is equal to, and that's 15 degrees. Technically, let me call it negative 15 degrees. Just keeping with the convention of how we measure these angles. The next one is going to be gravity. So what's the angle between our displacement and gravity? That's this angle right here. So let's call this theta sub G. And that is equal to, theta sub G is equal to, well, that's a right angle. It's 90 degrees, and really we should call it negative 90 degrees. Next is the work done by the normal force. The angle between the displacement and the normal force. So that's this angle here. Call this one theta sub n, and that is also a right angle. Call that one 90 degrees. And finally, the angle between our displacement and the force due to friction. So we're starting here, we're ending here, which means theta sub k for kinetic friction is 180 degrees. So keep those angles in mind as we're doing this problem. Those are the angles we're going to be plugging into our formula. So let's start figuring these things out. Got a new layer, and I'm hiding these layers. Okay, so first, to get let me just write down the formula again. Work is equal to magnitude of the force times magnitude of the displacement times cosine of the angle. So that means the work done by Alice is going to be the magnitude of Alice's force, which if I go back here, that is 625 newtons times the displacement, which is 3.25 meters, times the cosine of the angle. And again, the angle between Alice's force and the displacement is negative 15 degrees. So we have force, 625 newtons. Displacement, 3.25 meters, times cosine of negative 15 degrees. So if you put all that in your calculator is going to tell you 1962 is the number. If you're keeping 3 sig figs, that'll end up being 1960 joules. So put a box around it. We solved for the right thing. We gave it the right units. And we don't have a very good everyday kind of feel for how many joules of work are done when you push a couch. But that is a reasonable number. So I'm giving that one a check. The next thing we needed was the work done by gravity. So W sub G is going to be equal to the force of gravity times the displacement times the cosine of the angle. So let's go back to the sketch. So the force of gravity is 588 newtons. The displacement is 3.25 meters. It is just always that amount. It doesn't matter. This is an important idea. You can't say, well, gravity's going down, but the thing didn't go down, so therefore the displacement is zero. That's not how it works. The displacement is the way this thing is actually displaced, and that's 3.25 meters. And the theta, the angle between gravity and the displacement, is negative 90 degrees. So let's go back to this page. And, okay, our force is 588 newtons. Our displacement in all four cases, 3.25 meters, times cosine of our angle was negative 90 degrees. All right, so if we're looking at this, we're going to have some positive number times some positive number times cosine of negative 90 degrees. If you ask your calculator, that is zero. So positive times 0 is going to give you 0. So our answer is 0 joules. Which means, again, just to be clear on this, even though gravity is a force, the magnitude of which is positive, even though our displacement is not 0, the fact that our force is acting at a right angle to the displacement means that that particular force does no work. So it does make sense that we get 0 for this. So I'm giving it a check. Next, we needed to figure out the work done by the normal force. So work of the normal force is equal to, I'm not going to flip back. It was 750 newtons. The magnitude, again, is always 3.25 meters times cosine of the angle. And our angle here was positive 90 degrees. So again, we're going to have a positive number times cosine of 90 is also 0. So this is another force whose magnitude is not 0. The displacement is not 0. The magnitude of the displacement is not 0. But the angle is 90. Cosine of 90 is 0. So the normal force does no work. And finally, the last one is, what was the work done by the force of kinetic friction? So let's go back and look and get these numbers. So friction had a magnitude of 165 newtons. The displacement, the magnitude of the displacement is 3.25 meters. And the angle between that force and the displacement was 180 degrees. So our force, 165 newtons. Displacement, 3.25 meters times cosine of 180 degrees. So this time we have some positive number times some positive number times cosine of 180 is actually negative 1. So we're going to end up with a negative number here. And it's going to actually be negative 536 joules. So you put a box around it. And quick step, we solved for the right thing. We gave it the right units. We got a negative number. Does that make sense? It actually does, because friction is only ever going to do negative work. Friction will only take energy out of your system. It's never going to give you extra. So you give it a check. So hopefully this thing's making sense.